So in this video, we're going to see a graph theory based question, 2 marks question from the year GATE 2015, and it is based on the topic of minimum spanning tree. So let's see what the question is. Let G be a connected undirected graph of 100 vertices and 300 edges. So let's quickly make a note of it. We have G as our graph, which has vertices as equal to 100 and edges are equal to 300. Fine. Let's go ahead. The weight of the minimum spanning tree of G is 500. Okay, interesting. So they have mentioned the weight of MST of this graph. So MST of G graph has a weight of 500. Let's go ahead. Now when the weight of each edge of G is increased by 5, okay, then the weight of the minimum spanning tree becomes, and we have to calculate the new weight. So this is an interesting problem. We have a graph G which has 100 vertices and 300 edges, and then we have the MST of that graph with the weight of 500. Now they're increasing the weight of every edge by 5, and they're saying calculate the new weight of the MST. Now this might be a little confusing in the beginning, but if you really think about it, what we need is the number of edges in the MST. Once we have the number of edges in the MST, then we know that each edge has its weight increased by 5. So then we can find the additional weight, and then we can add to 500, which is the initial weight of the MST. So how do you find the number of edges in the MST from a given graph? Now if you really think about it, what is MST? Okay, MST is nothing but a tree. Okay, MST, what is MST? MST is nothing but a tree. Okay, so consider this graph here. Okay, let me draw a random graph to explain this concept. So this is a random graph. Okay, now if I have to, this is my graph G. Let me say this is my graph G here. Okay, now when I want to convert this graph to a tree, okay, let's say I want to convert this graph to a tree. It might be MST, it might not be MST, but let's just keep it simple. If I want to convert it into a tree, this will look somewhat like this. Okay, so what has really happened when we do this conversion from a graph to a tree is that the number of edges into this tree is equal to the number of vertices minus 1. Okay, if you note here, the number of edges is nothing but the number of vertices minus 1. That's how we get a tree. If we add more vertices, if we add more edges into this, then that won't be a tree because we'll get a cycle into it. So any tree, doesn't matter if it's a minimum spanning tree or a BFS tree or a DFS tree, any tree that we get from a graph, there the number of edges in the tree is going to be 1 less than the vertex. That is the basic definition of the tree. So even in this graph's MST, so this is my graph, even in this graph's MST, the number of edges in the MST is going to be 99. Okay, 1 less than the vertex is going to be 99. So let me write it down there. I'm going to have 99 edges. 99 edges in the MST. Okay, so if you really think about it, this information that the graph has 300 edges is actually useless, and it is purposely given to confuse the students so that they will keep on thinking that, oh, if there are 300 edges, then how much will be the number of edges in the MST. Actually, this information is given just to confuse you, just to misdirect you, so you can very conveniently ignore that piece of information. What we know for sure is if there are 100 vertices in the graph, then there will be 99 edges in the MST. Okay, and now weight of each edge in the MST is increased by 5. So we will have 99 into 5, which is equal to 5 9 is 45 and 495. So 495 will be the additional weight that the MST will carry, and the original weight was 500. So now the total weight will be 500 plus 495. So 500 plus 495, that is equal to 995. So 995, that is what they have asked. Here we are. The weight of the minimum spanning tree becomes, so the new weight of the minimum spanning tree becomes 995. So 995 is our answer.